Hello everyone. Today we are from Group 2 and we would like to present our group task week 5 about DBMS in business organizations. So the definition of a database management system, or DBMS, based on the exact wordings of the textbook, it is the program that manages and controls the data and the interfaces between the data and the application programs that use the data stored in the database. So, in easier words, or in other words, a DBMS is basically like the software that acts as a bridge between users and the database. It ensures that the data is stored, retrieved, and updated efficiently and securely while also hiding how complex or how the data is actually physically stored.
Okay, so for the next one is on how business organizations are using their current DBMS. And for daily transaction is that a DBMS record everyday business activities like sales, payroll, or purchases. And the next one is ERP integration on how ERP system run on DBMS to connect departments in an organization, such as accounting, HR, and supply chain, so that it could share the same data. And the example of that is that if HR updates on the employee info, accounting sees it immediately for payroll. And the third one is data analysis, is that company use DBMS to build data warehouse, which helps them to see patterns and plan ahead. And the fourth one and the last one is that decision making is that manager can run queries and reports from the DBMS to support timely and accurate decisions on how the example of a manager can generate a sales report to decide which products that actually need some restocking. And therefore, we can conclude on how companies use DBMS to run daily operations, connect departments, analyze data, and support faster decisions. Without DBMS, handling today massive data would be nearly impossible.
Next is relational DBMS are based on relational data model, where data is stored in tables, rows, and columns. They are widely used in industries such as finance, e-commerce, healthcare, and large enterprise systems because of their strong support for data integrity and complex queries. Some examples include Oracle Database, which is powerful and widely used in large enterprises, Microsoft SQL Server, known for its strong integration with Microsoft ecosystem, MySQL, a popular open source database, especially for web applications and startups. PostgreSQL, also open source, highly reliable, and equipped with advanced features. And lastly is IBM DB2, which is trusted by banking and finance industries, as well as large-scale organizations. These relational DBMS products continue to be essential for managing structured business data efficiently.
Besides relational database management system, there are also non-relational DBMS, or so we could call NoSQL. They provide flexible schemes and scale easily with large amounts of big data and high user loads. And these NoSQL databases are used for their ability to handle the large volume of diverse, unstructured data with high scalability and flexible schemes, making them much ideal for big data and rapidly changing data model. Some examples of non-relational DBMS or NoSQL are Couchbase. This Couchbase is a memory-first database that stores data as JSON documents and provides good performance and scalability. The second is MongoDB, which also stores data with a document, the same, which is JSON, for better data type support, and they improved indexing and querying. The third one is Cassandra. They are highly scalable white column store and is designed for handling large data across multiple servers. And lastly, the Amazon DynamoDB. It uses a key value store that is used for a wide variety of semi-structured data-driven application.
So next, we get to the strengths and weaknesses of the relational database. And the first strength is their data integration because they have one unified database. They minimize data redundancy and inconsistency because you only need to store them once. And they are data independent because they have a modular approach, so the system and the database is separate. They have a cross-functional analysis. So they can retrieve much more relevant information compared to non-relational database. And lastly is their data integrity because they have features that ensures the database remains consistent and reliable. But their weakness is also the fact that their structure is rigid because they have a structured format, and they have challenges in scaling horizontally because it is expensive to scale them across many servers, and they are not suitable for unstructured data. Next. And regarding the strength and weaknesses of non-relational database, the strength is that they are highly flexible because you can define your own schema and you can define your own structure. In terms of scalability horizontally, they are much cheaper than relational database. They are also high performance, and their data types can vary, so it's not just structured but also unstructured and semi-structured. And their weakness is that their data is usually redundant because you need to store more than once depending on the application that you use. Their data could be inconsistent, and they like that, and they like integration. Their data is also dependent on the application, so it's hard to maintain the data, and they also have anomalies which could make them corrupt and leads to unintentional loss of information.
So to conclude our presentation, database management systems or DBMS are crucial because they act as the best backbone of modern businesses, ensuring that data is stored, accessed, and managed securely and efficiently. Relational DBMS like Oracle, SQL Server, MySQL, and others remain dominant thanks to strong structure, integrity, and reliability. However, non-relational DBMS such as MongoDB, Cassandra, Couchbase, and DynamoDB have gained popularity for their flexibility and scalability and the ability to handle unstructured data. Each model has its own strengths and weaknesses. Our DBMS is ideal for consistency and integration, while no SQL excels at adaptability and large-scale performance. Because of this, many organizations today choose a hybrid approach combining both models to balance reliability and innovation data in management. So that concludes our presentation. Thank you very much for your attention.